All right, welcome, ladies and gentlemen, to section 4.1. This is the introduction to our trigonometry. We've finally made it there. Today, we're going to be looking at really just an introduction to trigonometry, basically looking at angles and their measures and learning new ways to write angles. So we know about degrees, but we need to learn about a new way to describe angles. And let's go ahead and begin with just what we know to begin with. Now we're going to look at something called DMS. And DMS stands for degrees, minutes, and seconds. And what this is it's a way to describe an angle that might be 23.17265 blah, blah, blah. And in the real world, this is what would actually show up. We would not see this 23 point blah, blah, blah. We would see 23 degrees, 13 minutes, and 12 seconds. So what this is the normal way. I call it the normal way because this is something we have grown up with. We've grown up with this idea of degrees as a measurement of an angle. We'll get to the non-normal or the more mathematical way in a few minutes. First of all, a degree, as we understand it, is if we had a straight line or a straight angle, that angle is 180 degrees. That means 1 degree is 1/180th of a straight angle. We should know that. We've learned that in geometry. We learned that before geometry and all that sort of fun stuff. Now, minutes and seconds work exactly like you think they would work on a clock. There are 60 minutes in an hour, and there are 60 seconds in a minute. So 1 minute is 1/60th of a degree. And likewise, 1 second is 1/60th of a minute, or 1/3600th of a degree. Those little fractions actually come back to help us a little bit later when we try to do some conversions. These types of numbers are usually used in navigation. Like if you were on a plane or if you were on a boat, we use navigation based off of north. And we call it bearing. Bearing is measured clockwise from north. So if you were to think about this, 23, 13, 12, as a bearing measure, remember north is here, east is here, SW. 23 degrees, 13 minutes, 12 seconds. We understand that going from north to east is a 90-degree turn, which means 23 degrees is going to be approximately here. So we could say this is approximately 23, 13, and 12. Note the symbols, by the way. I did not mention this, but this little O0 thing, that's degrees, you know that. A single dash up here, an apostrophe, is going to be minutes, and the double or the quotations is going to be seconds, just by the way. All right, let's go ahead and move forward. Let's say we wanted to convert between decimal and degrees, minutes, and seconds. So I want to take this decimal and I want to change it to essentially 37 degrees, some minutes, and some seconds. Sorry, I just did that wrong right there. 1 dash for minutes. And we need to figure out how we're going to do that. So we're going to use the decimal part to find the minutes. We already know that it's 37 degrees and something else. So we're going to take the decimal, which is 0.425, and I want to multiply that by 60. because this is 0.425 of a single degree, but that's going to be 0.425 of 60 minutes. And if we were to multiply that by 60, we would get a new number that would represent our minutes. And if I did that here, 0.425 times 60, I get 25.5. That means I have 25 full minutes. And then I have a decimal part in my minutes, which I can use that to calculate the number of seconds. So I'm going to take 0.5 and multiply by 60, because there are 60 seconds in 1 minute. And since we're looking at half a minute, it's going to be 30. You can do that without a calculator. So 37.425 degrees is going to be 37 degrees, 25 minutes, and 30 seconds. All right, so that one's not too bad. We use the decimal parts and multiply by 60s in order to calculate the two missing pieces. In order to do the other direction, we understand that this 30 is 30 out of 60. And we understand that this 25.5 is out of 60, right? Because it's 25.5 out of 60 full minutes. So in order to convert the other direction, we're going to take 42, which is the full degrees, and we're going to add 24 out of a total of 60 minutes. And then we're going to add a 36 out of a total. Now here's where you want to be careful. We're going all the way to degrees. So I said earlier that this was 3,600 seconds in 1 degree. And if we do that really quick on our calculator, I get 42.41. Oops. On this, I do want to make a note of negative angles. So if we were to take positive angles are measured clockwise from north. Negative angles are measured counterclockwise. The reason I'm going to say this is because if I had negative 12 degrees, negative 12. Negative 12 degrees, 10 minutes, and 13 seconds, I need to make an understanding here. The entire angle is negative, not just the 12. So when I do my conversions, I need to take the negative of 12 plus 10 over 60 plus 13 over 3,600. That way, I should get a negative 12 point something, whatever that something is. If I did not use parentheses, usually people get a little bit confused and they say it's negative 12 plus these two numbers, and we're going to get some wrong things here. And in case you wanted to know, this is going to equal negative 12.170. I guess we'll go all the way out. 12.1703. All right, so that's converting between the two. I say better for the calculator because all you have to do is plug it straight in. This one takes a couple steps on your calculator. Okay, one of the other things that comes up in this lesson is how to add and subtract in DMS. So if I wanted to take 34 degrees, 12 minutes, and 16 seconds, and I wanted to subtract, now let's go addition first. If I wanted to add 12 degrees, 19 minutes, and 54 seconds, I could add this straight down. So 54 plus 16 is 70. 19 and 12 make 31. And 34 and 12 makes 46. Now, here's the problem. We know that there's only 60 minutes and 60 seconds. That's all we're allowed in each thing. So that means we have to carry the extra 10 seconds that got counted here, right? There are 60 seconds in a minute. So this now becomes 10, and this becomes a 32. All right? Both of these numbers have to be less than 60. So we're going to carry. And it goes the same for borrowing, I guess, if you want to call it. And I want to subtract 12 degrees, 19 minutes, and 54 seconds. So if I wanted to subtract, well, I can't do 16 minus 54, so I need to borrow a group from the minutes. Well, by borrowing 1 minute, I've actually borrowed 60 seconds, so this becomes 76. 76 minus 54 is 22. And again, I have to do the same thing. 11 minus 19 doesn't work, so I need to borrow. And I need to borrow a whole degree. And 1 degree is worth 60 minutes. And so therefore, I have 71 minus 19 is 52. And 33 minus 12 is okay because that becomes 21 degrees. So remember to carry and borrow when you try to add or subtract in DMS, or degrees, minutes, and seconds. The subtraction comes in handy for a couple of your problems directly today. Okay. This is the humongous new thing you've never heard of before in your life, and if you have, you don't know what it meant. All right, radian measure of angles is something we do in math. Well, all the way through calculus. Everything we do in calculus must be done in radian mode. We can't do anything in degree mode, really. So when we start to convert into radian mode, we need to understand what a radian is. A radian is this. If we had a central angle of a circle, has measure 1 radian if that angle intercepts the arc with the same length as the radius. Okay, so what does that even mean? We have a circle, and we have our center. A central angle looks like this, right? The angle is here. This angle has 1 radian. It's called 1 radian, the measure of the angle. If this radius from here to here is the same length as here to here. So if this arc on your circle is the length of 1 radius, this angle here, this theta measure, we kind of call it theta, by the way. Theta is a Greek letter. Everything we call angles from now on, for the most part, will be called theta. It's a circle with a line through the middle. Theta is equal to 1 radian. So if you notice, it actually takes, we've done this before back in when we learned first steps of geometry. If we take a radius and we go around the circle, that radius will reach around the circle a few times, right? It'll actually reach around the circle 6 times with a little bit left over. So we have 1, 2, 3, 4, 5, 6, and a little bit more radians in a whole circle. And if you understand that, well, we'll get to that in a minute. The whole idea of 6 and a little bit more has to do with pi, and we'll get to that in a minute. So actually, I'm going to get to it right now. So we're going to say how many radians are in a whole circle. We said it's 6 and a little bit more. Well, we know, as I mentioned, taking the radius and going around the circle a few times, that means I'm going around the circle. Around the circle is the circumference. And the circumference of a circle is 2 pi times my radius. Well, if this is 1 radian, I look at it, I have 6 and a little bit more. Well, guess what 2 pi is? It's equal to 6 and a little bit more. That means I have 2 pi as an entire circle. We understand in degrees that that's 360 degrees. We know that there are 360 degrees in a full circle. However, we now know that there are 2 pi radians in an entire circle. And if we go a little bit farther and get down to what we can use as a conversion factor, in a straight angle, meaning 180 degrees, well, 180 degrees is half of 360, which means it's half. This is the most important thing that we are going to start off with in Chapter 4. Pi radians is equal to 180 degrees. We could say that up here as well. 2 pi radians is equal to 360 degrees. So when we look at the short conversion factors, pi is equal to 180 when we think about radians and degrees. We're going to get to those two later. I think they actually show up in a textbook problem, so we're going to look at those two answers later. So one thing I want to notice, really want to point out here, if we break up a circle into 360 degrees, each 1 degree is pretty small. But if we break a circle up into 1 radian, there are only 6 and a little bit more radians on every circle. So 1 radian is actually much larger than 1 degree. Now let's look at how to convert. Knowing that pi is equal to 180 degrees, we're going to use this fact to help us convert. So if I was given 135 degrees and I wanted to rewrite it as radians, I'd have to multiply by my conversion factor. And in this conversion factor, I would have to divide by degrees in order to cancel degrees, and I would have to multiply by radians in order to cancel or to introduce radians. Well, we're going to use these two numbers as our conversion unit because pi divided by 180, pi radians over 180 degrees is equal to 1. So we are going to use going from using these two things, they're two different things. This one, the top one, since we're dividing by radians, this one is radians to degrees, and this one is degrees to radians. This is super important for us to know. And you guys should know this just off the top of your head. Once you get the hang of this, this should just be automatic for you. So if we were to think about this as how many radians are in 90 degrees, let's just do the conversion because we need to know how to do this. Most of us will probably be able to know this on our head very, very quickly if we've paid attention for the last 5 minutes. 90 degrees times pi over 180 degrees. Well, 90 over 180 is 1/2, so I get pi over 2 radians. So 90 degrees is the same thing as pi halves, and that should have made sense from the last slide. Since we said pi is equal to 180, that means 90 is equal to pi over 2. And if we want to go the other direction, we would say, okay, pi thirds radians. Well, pi thirds is really just, if you want to think about it really quickly, it's just a third of pi, and that means a third of 180. But let's look at it as conversion. Here we're going to cancel the pi's, and we get 180 over 3, and that's going to equal 60. So a good thing to know, again, is 60 degrees is equal to pi thirds. You will be getting so good at this that I could say, hey, what is pi fourths? And you should automatically be able to tell me that's 45 degrees. All right, some of the things that we're going to be doing using this stuff is arc length. Arc length just means what is the length of the arc. Given some angle, some circle with a central angle theta, and theta is in radians because we're in radians, this length right here is what we call S, which is arc length. So the arc length formula is probably one of the most simple formulas we're ever going to use. S, the arc length, is equal to the radius times the central angle. So S is arc length, R is radius, and theta is the central angle measured in radians. And it must be measured in radians, or you're not going to be able to do it. So I will put over here on the side. If you have a central angle in degrees, you have to take your degrees and you have to multiply it by pi over 180, so everything is in radians. All right, question that I could ask here. Find the perimeter of a pizza slice that has been cut from a 12-inch pizza at a 40-degree angle. Not too bad. You have a circular pizza. You have a 40-degree angle cut out of it. That's not 40 degrees, by the way. And it has a 12-inch radius. Your pizza slice is right here. So I know that perimeter is equal to my radius plus the length of the crust. So it's 12 plus 12 plus S. S is R times theta. So it's R times theta, which is 40, but that's degrees, so I need to multiply by pi over 180, and I get a very simple answer of 12 plus 12 plus 12 times 40 times pi divided by 180 is 32.38 inches. All right, so that being said, let's see what we got here. Oh, look at there. That's the assignment already. The assignment is relatively short, I believe, but it's enough sampling that you will get an idea. Now notice all of these are even problems. If you want to know if you're doing a problem right, do an odd problem and check the back of the book. Oh, I guess I did assign one odd problem. But if you want to know what you're doing right, do an odd problem. Check your answer in the back of the book to see if you did the problem correctly. I will have an assignment sheet hopefully for you guys by tomorrow. I have to make some tweaks on it from last year. But other than that, I hope you learned a lot today, even if it wasn't very long lesson. Hope you learned a lot. I will see you guys tomorrow. Let's enjoy our trigonometry.